Hey all, it's Lawrence from Express Unity, and today we're going to be messing around with some inverse kinematics, and we're also going to fix our head movement with the current camera. So, the first thing that we want to do is on our soldier model, we are going to want to change the animation type to humanoid, and we want to set the avatar definition to create from this model. If we click apply and then click configure, if the model is rigged in a way that Unity can understand, then Unity will automatically fill out where all the bones need to be. If it's not, and you know your model it has the right amount of bones for Unity, you're gonna have to drag and drop them into all these areas in order for the model to work. Once you're happy with it, you can click on muscles and settings and move a few of these sliders. If you think they move correctly, then you're good to go. Click done, and we'll go and take a look at some code. So, just before we start, let's go ahead and get the soldier into our scene so we can edit it. And we have the current camera set inside the bone for the head. So we're going to want to do a few things. I've also increased the font size, so hopefully it's easier for you guys to see. So if we're going to need a public transform for the head and a public public vector 3 for head offset. We're also going to want a public transform, and gonna call this head lock. Alright, so I almost had it correctly in the last video. I did have to just look this one up a bit because doing head movement isn't something I've done recently, and so I kind of forgot how to do it. But we're going to want the void late update, and within this we're going to say head.transform.rotation equal camera.transform.rotation. Then we're also going to want to times it by the head offset. We're going to want to times it by quaternium.euler and then head offset because it's a vector 3. And if we play this now, after we've added our bone, this will work, but you'll see a few problems. So once it's compiled, so we're going to want the head. We don't need to worry about the head lock for now because we haven't done anything with it. So just save this and play the scene. I should probably disable the model, but it doesn't matter. Once we start the scene, it's going to disappear anyway. Photon will automatically remove it because it's an unassigned object. Okay, so you'll see our head is not right. So if we go into our soldier and mess around with our head offset until we're happy with where it's currently positioned. Might be a bit too far. Let's mess with the Z. Okay. X. Okay, it looks pretty good. Maybe fix the tilt just a little more. Yeah, okay. That looks alright. So while we can move the camera up and down and the head follows, the animation still plays left to right. So we're going to need to do some further coding. The reason why this does it and it doesn't lock the animation to the camera is because the camera is also parented onto the head. So this camera is getting the animation applied to it. So even though we're setting the head to the current camera rotation, it's still playing that animation. So we're setting the Y because that's something we're doing and not the animation. So that's why the head follows that correctly. So what we need to do real quick now that we've found our offset is copy the movement component. Then we want to paste the component values, and we're going to want to drag and drop the the camera, and wait, was that? The camera, and then not the neck, the head again, and then we'll just apply that. Now, we want to use, so the head goes into the head, and then we'll apply. So we want to use another game object that is outside of the current head parent. So we want to create one in the spine, and I'm just going to call this headlock. And this is the rotation that we're going to be using for all the other axes. So let's go ahead and above head, let's create a new quaternium. We'll call it rot. And we want to equal that to quaternium.ulla. And then we'll say head offset dot what was it? No, it's not head offset. Sorry, it's headlock dot transform dot ulla angles, and then this will be X, I believe, and the other one will be Z, I think. And then the next one is going to be our camera.transform.ulla angles. I think that's how you say it. I have no idea. And then this is going to be our X, I believe. And it's going to be a negative value. Now, on top of that, we're also going to want to times it by our head offset. And this is going to need to be quaternium.ulla as well. Alrighty, so instead of passing this through the rotation, we now pass rotation. And if we play this, apply the soldier, the animation should now be locked to the headlock rotation. So let's just quickly give this an apply. Let's play. So, something weird's happening. Okay. So, you can see that the rotation is currently just facing some random direction. Not even the camera's moving, right? So that is probably to do with the wrong axis. So it could be this one. It might actually be Y. Let's save that and see if that was actually why it wasn't rotating correctly. Again, because all these bones are different rotations and flipped around, you're gonna have to mess with the offset because sometimes the X will be in the Z position and it'll just be weird. Okay, so it is currently working. We need to change the offset again. So let's see if we can figure this out, where the offset should be. Wait, if we set that to 0, okay. Okay. I think that could be pretty spot on. And now if we look up and down, it works. You will see that the head no longer rotates left to right. It still has a slight bobbing motion from the animation. You'll see though that the neck still plays that animation of looking left to right. You can see the mesh kind of bending there. Don't really care about that at the moment. It's not a big deal. It's not going to affect the gameplay in any way. Players might be like, that's kind of weird, and have a good laugh over it. But if you want to fix that, basically just make it equal to the headlock, and you should be fine. So now, if we walk around, it looks just fine. If we run, camera is also fine. Has a really big head shake, but I mean, that's kind of cool. So I'm going to right click the movement, copy component, and then we are going to paste component values, and we're going to need to drag and drop all of these components again. And we are going to apply. Alrighty, so currently our animations are really like harsh. So I'm just trying to think how we can do this. What we could do just trying to think here. We could always do some random stuff like I think it's mathf.lerp, and we can lerp between let's say can we get a float? I think we can, yeah, get float. So let's lerp between the current move float to 0.5, and I think we use time dot can't remember if it's time scale or delta time, but we'll just do that. And we will maybe say 3 times and then time.delta time. So now let's do that basically. So now we just change everything to have this lerp. Like so. Alright. And then the the run one will be set to 1. So if I've done that delta time correctly, we should actually see a smooth transition of the animation now, rather than it kind of instantly switching to the current animation. If we play, and if we walk, okay, then if we run, okay, I think we may have missed one, because when I start, yeah, this one down here. So this is going to be set to 0. So I think, let's just change them to 1. We're going to make an actual value for this. Actually, let's just do it now, otherwise we're going to be here for years. So let's go ahead, create a new public, and we'll just call it, and make it a float. We'll call it animation speed. And then let's just set all our animation speed to, or all our set float values to the animation speed. It should be called transition speed rather than animation speed, because it doesn't control the speed of the animation playing, it controls the speed of it transitioning to the next animation. So if we play this now, the value should be set to 0, so that should mean it instantly moves. Oh no, doesn't do anything. Okay, my bad. The higher the value, the faster it transitions. So let's make the transition speed a 10. Let's see where that gets us. Okay, not bad. Let's I think 10 might be a bit too fast. Let's go to a 5. Okay, it's not stopping. Oh, okay. Oh, I know why he's not stopping. Okay. So, the reason why he's not stopping is because in order for lerp to work, it needs to be run every frame. When we get a key up, it's only being done once. So, look, for now, to keep it simple, whenever we switch back to just a normal animation of it not moving, let's just not lerp. And then we'll figure out a way to make it actually work. Oops, we don't want to set the actual keys, we just want to set the get up to 0. We'll probably end up doing a coroutine later on, but for now I just want to make the initial transitions to run and walk smooth, because otherwise the camera gets affected by that sudden switch, and it looks really bad for the player. Whereas if it transitions smoothly, the player has time to react and adjust the camera to however he feels fit. If we walk and then we run. Oh, come on. That's not even doing it at all. So that's set to 0 on get key up. This is set to 0 on get key up. Get key up, set to 0. Get key up, set to 0. Oh, wait, hold on. We forgot to actually save our transition speed, so let's just make it like a 5, and we'll apply it. Alright, so this should work now. Yep, and you'll see if we stop, the animation just cancels out. That's alright. We just want to make sure that the initial transition, you see how much better that looks when I run? How instead of it just instantly moving down to the ground, it so this is, that's walking, then we transition to running, and he transitions to it smoothly. It's just moving back how it doesn't transition. So we'll need to fix that later on. Yeah. So, yeah, this isn't really the main focus of today's video. It was more the head and the kinematics. So, what I'm going to do now is let's just create an object. We'll create an empty object within the soldier. This is just a test. We'll even name the object test. Now, if we go and call a function called void on animator IK, one thing we do need to do, sorry, is on the animator, I may have set this before while I was learning. Yeah, I did. So in the layers here, there's this little setting by the base layer. If we click that, there's a thing here that says, that's called IK pass. By default, it's checked off. You want to make sure that it's checked on. So after you've done that, let's go back to the code. And now we have a few things we can do here. So if we say anim.set IK position, then we want to set the IK goal, and let's say right hand. And this is going to be set to the position of so let's maybe have public transform, and we'll call this gun hold 1. So if it's a pistol, would only fill this in. If it's like a proper AR, then it would have 2, so both hands go and hold it. So for this, basically we want to say gun hold 1 dot transform dot position. Now, before this, we want to set the weight of the current position. Not that, we want to set OK position weight. And we want to set it to the right hand. And we'll set it to 1. So what the weight does is if it's set to 1, it'll completely override that bone and make it the current position of this transform. If we set it to 0.5 and there is an animation playing, it'll play the animation softly and also override it to the current position. So for now, let's just set it to 1. If we save this, go to our soldier, and we'll grab, once it's loaded, the test gun hold and apply. Okay, so it's probably already a problem because I don't see anything happening with the hand. So if we go here, oh actually it's down, maybe that's fine. Yeah, nah. Let me see. Could be because it's again parented to the soldier. We take it off. No. I think let me quickly see something actually. With the current soldier that we created a humanoid from. Okay, I don't think it's using the right. Yeah, okay, let's drag this into it. Binding warning, some generic clips animated that are already bound by, these transforms can only be changed by humanoid clips. Okay. Because all the animations for this model seem to be created by Legacy, this might not actually be a good model. Because we're using all the new systems. Let's just see. Okay, yeah, oh my, something's messed up down there. Oh boy, he's in pain. So let's oh my goodness. Okay. Yeah. You can see how his hand follows now. But oh, that sucks. We've got a bad model. Because it's using the legacy system, it's not gonna want to. Alright, we'll put it back to default. Yeah. Because we've got a model that uses the legacy system and its animations were made using that, it doesn't like going to humanoid. So we're quite literally going to need to find a model that's compatible with what I'm trying to teach you guys. So yeah, sorry guys, I should have checked the description of that model before I downloaded it. It was just free and I was like, yeah, might as well do it. So might as well go to humanoids and see if there's anything for the cost of 0. Some sci-fi robots. With planar Maya information, textures, no humanoid character contains 12 animations: crouch, crawl, jump, run, walk, idle, stand. Okay, that's good. Okay. I mean, the game that I'm planning is going to be sci-fi anyway, so maybe these models will suit it pretty well. I'm going to import this. We're going to have to kind of backtrack a little with me doing this. But yeah, hopefully you guys don't mind. Alright, so before we even do anything with them, let's go ahead and... So sci-fi robots, prefabs. Let's just get the red one. Damn, it's a pretty nice model. Okay, so let's go to model. Robot. Okay, he's already set to humanoid by default. Alright, that's good as... yeah, I'm just gonna cancel that. Alright, so now comes the annoying part of basically doing what we did a few episodes back for our soldier. And that is literally doing all of this again. So setting up our character again. We're gonna want a capsule collider. And we're gonna want to just set the capsule collider to a decent size and height. That looks alright, not too fast. Okay, we're going to want the photon animator view. And we're going to want the photon... Oh wait, we already got a photon view from that. Remove. Then we're going to want our super sync that we created. So now we want to have our animator view as a observable and our super sync. Now we're gonna need to create another state. Actually, we can just use the player state, and we can just go into the blend tree and go to the animations of the robot and literally just use these. So we have our idle animation. I'll just play it. That's alright. Okay, and then we have our warp. Oh yeah, we're probably gonna want to transition. What is... Please don't tell me this is broken. We have a... Oh, hold on. I don't think it changed because I tried dragging the model in. There we are. Okay, and then we have our run. So now if we transition... Alright. Okay, that's awesome. Perfect. So let's go ahead, go back to our scene. Stop that. And we want to make sure that is there. We'll give save. And then we want our movement script. We want to set all of these again. So no, we want left to be A, we want right to be D, forward to be W, backward to be S. Move speed was really high with the other guys, so I'm just going to change it to 10, maybe 15. And I'm now going to move the camera on this guy to the robot. Continue. And we will basically do it what we did on the other rig, but on this guy. Move the camera to the head. And we're also going to want the... one thing we're going to need to do is reset the position transform for the camera. And I'm just going to enable it while I position it. And so we'll probably put it about there. And then the same for our headlock. Except we just want it on the spine. And we want to reset position. Or might even want to reset the rotation. Okay, so that should be it. Now we just want to populate it. So we got the camera. We got the head bone, and we got the head lock. And we'll set the animation speed to 4. Actually, wait, it was 5, wasn't it? Let's apply this. I'll call it robot. I don't think I've missed anything here. Nope. Okay, so let's make that a resource. So in our scripts, we now need to go back to the multiplayer manager. An easier thing to do for this. Wait, where do we spawn it? Not multiplayer manager, it's in free-for-all. A easier thing to do for this is to just make a variable in the inspector, but for now we're just going to make it a robot. And now we're going to have to mess with the offsets again to fix whatever offset we need with this current player. Another reason why all those offsets could have been broken is because that wasn't even a humanoid model. It wasn't compatible with it. Also, this might give us errors because of, yeah, the hand position. I'm just going to give the lobby camera to the position for a sec. Just so that I can unpause it and actually do stuff. Okay, you can already see that the hand's out and working. So let's... Okay. So the... Where is it? The offsets. Let's try and give this a fix. So let's just keep it to 0. Okay. Oh man. Okay, let's just copy the component values. Oh, did I paste them? That's not what I want. Copy component. And let's get the robot back out. And then we want to paste component values. And we're going to want to just add everything that we had back in. So we had our head lock. Had our camera. We then had the head bone. And I'm just going to give it the directional light. Just for now, just so it doesn't give us an error. So, this is kind of annoying now because I need to figure out the correct rotations for this model. Actually, hold on. Let's try something really quick. Let's say animation dot set look at position. Let's set it to the camera dot transform dot rotation. Wait, is it dot position? And then again, we want to set the look at weights to 1. Let's actually see if that works. If that works, that'll be super easy. We don't have to deal with anything. What value hasn't been signed? Come on. Come on, I signed it. Put it in there. Do that. I mean, hey, the head doesn't rotate. Doesn't look around with this method, but actually maybe it does look around. The camera's been affected by his hand is just up there chilling. Oh, the animations are pretty smooth as well, with the walking, running. But yeah, you can see if we get the wherever the directional light is here. So he actually attempts to, his hand will follow the light. So just imagine that we have these points on actual weapons, right? So he'll automatically find the points on the weapons and he will position his hands onto the weapon correctly. So that's pretty cool. Got that working. I'm kind of sad because that does work, but it doesn't work. So actually, is there a set look at rotation? Let's set look. No, there isn't. Damn. Okay, so maybe all of these are correct now. So let's say X. Oh, actually, they're already set. Alright, let's go Z. Basically, we're just gonna have to mess with these values until it fits the current rotation that this model is using. Again, we're gonna have to drag the directional light. Ah, man. Is it the camera axis now? I don't know, let's try Y. Now that it seems like it's in the correct rotation and everything. Okay, again, we need to drag in something for it to look at. Oh, actually, no. It could be maybe because before we set camera on the X, it was weird. Maybe we got to do the same here. Set the camera on the X. Let's see how that does. This video is getting pretty long, and all it's been is me trying to figure out this one thing. But once we get it to work, because we're just going to be reusing the same model, basically giving it the same color, don't really need to worry about it. Oh, is that... Wait, what the hell? Why is it using... Did I leave the other one in there? Put the camera... Did I not save it? For the sake of us not needing to keep dragging that in, I'm just gonna put the game object in here. So that we don't need to keep adding that damn light in. Oh, okay. I see. His head just stays in the same spot now. See, it wasn't staying in the same spot before. Oh, man. Let's see. We Can't try and salvage this somehow. Oh, goodness. Y and Z. It was rotating before, but then the camera was getting the incorrect axis, so basically just try and figure out how we can solve this here. Oh, I think I did it. We did it. All right, let's try and get the camera centered again. Okay, so now let's go ahead and... Oh, that's not what I want, sorry. Now we're gonna have to change all these offsets again. Wait, these are the same thing? We may have a problem here. Let's copy component. And then we'll paste the component because that was working. Paste values, and we're gonna have to do that whole thing again, so hold on. You guys can make something where it'll automatically find these components, but for now, I'm not going to bother with any of that. Okay, so let's see. We have... It's weird, because it should work. No problem with it. I'm not doing anything differently. Anyway, the good thing is, it's in the correct rotation. It might be a little bit too high, but if it works, then... Okay, so we're looking up and down. I think that's it. Oops. Wait. Some weird things happening right now. Let's So for some reason the camera seems to just clamp. So we can rotate. Oh, yeah. Oh my goodness, it's just one problem after the other. Let's see what happens if we parent the camera onto camera end. Test this set. And then we'll get back to it another episode if it doesn't work. It's sad that we couldn't figure it out this episode. Yeah, once it does that weird flip, it could be because this is inverted now. So if we actually fix it by removing the negative, maybe that will have an effect on how it is. Okay. Okay. Yeah, that did fix it. Sweet. Now we got this dude that looks around with our camera up and down. We can run. And then we can also, with the inverse kinematics that we did, we can move this current game object around to actually move his hand real time. So that's cool. So he's waving to himself. So yeah, we can just keep his hand there. We can let it chill. Move it more to the center so the camera can actually see his hand. And then just go for a nice walk with your hand in front of your face. Some of a nice slap. But yeah, so we've got a smooth animation when we initially start, and then when you run it gets faster. So next episode, I'm really happy with this. So next episode we're gonna try and transition back smoothly, and then we're going to be working on our weapon system. Not going to, we might sync stuff, but for now I want to kind of get a random weapon in the scene with kind of these anchor points, and if we pick it up I want him to automatically place his hand on those anchor points. So that's what we're going to be doing next episode. So I hope you guys enjoyed this video. If you did, give it a like, give it a subscribe, really helps me out. Again, sorry that this episode was more me just debugging just random rotations. We did have to swap out our character because of that legacy character. But now that we've got a nice working character who looks pretty good for a damn free character, like this guy is sick. But now that we have a free guy, you guys can download it as well. But yeah, next episode hopefully should be getting into some interesting stuff now that all the main boring stuff is over. I've shown you guys how you can do inverse kinematics, so maybe you guys can skip ahead and do a little bit of homework and see if you guys can figure out a system on your own before I make the next video. But yeah, also don't forget that I have a Discord server, so if you guys need any extra help outside of the videos, go ahead and check out the Discord server. Alright,